When we are going through electromagnetic radiation, it's important that we consider the basic idea of wave into consideration, because electromagnetic radiation is also a wave. It also possesses wave-like characteristics. Electromagnetic radiations do not require any medium to propagate, and you see that ordinary light, X-rays, gamma rays, that they fall under this electromagnetic radiation. They are the electromagnetic radiation. So before we delve into this concept of electromagnetic radiation, it's important that we know what is wave, the basic thing. So wave is generally a kind of disturbance that originates from some vibrating source and travels outward. That's just the wave. The disturbance is the wave. Wave has this certain this pipe characteristics that we need to know in order to define a wave. So the first that we are going to study is this wavelength. So wavelength is the distance between two crests or trough. The wavelength determines the color of a beam of visible light. So if this is the wave, if we consider this as the wave, so these two are the crest, and this down here are the troughs. The distance between these two peaks is the wavelength, and similarly the same thing for the troughs as well. The distance between these two troughs is the wavelength. Between these two troughs. Now the next is the frequency. Frequency is generated as nu, or can be called as V, just for a simpler, just to not make it complex. So the frequency is the number of times a wave passes through a point in 1 second. So it is just the it is expressed in cycles per second or hertz in units. It is also related with the wavelength as the inverse. So if the wavelength is high, the frequency is going to be low. That's the inverse relation between these two. Then now the third one is velocity, the distance traveled by the wave in 1 second. So the distance traveled by the wave, the distance travel, how much the wave has traveled in 1 second, that is the velocity. It's the same for the electromagnetic radiation, that is this 186,000 miles per second, 3 to 10 to the power 8 meter per second, or 3 into 10 to the power 10 centimeter per second. Some radiations have different wavelength, and some so they might have this different value of velocity as well. In order to calculate this velocity c, we need this formula, that's e equal lambda nu. And the fourth one is Wavenumber. It is denoted by nu bar, or like a b bar as well. So it is the number of wavelengths per centimeter. It's the number of wavelength that is in a centimeter. It is the reciprocal of this wavelength. This is how it is calculated. And the fifth one is the amplitude, which is denoted by the smaller letter a. So it is the height of the crest and also the depth of this trough, that's the amplitude. So it tells about it is related with the brightness or intensity of light. So yeah, it is related with the intensity. So this is the basic concept before getting into the idea of electromagnetic radiation.